Hi, I'm Michael Johnson, and I'm a physics major at the University of Dayton. Right here, I have a gravity well. And, yeah, so I'm going to teach you a little bit about gravity today. So what we have here is a giant elastic sheet, and this is going to represent space-time. Now, you're not really going to learn about this until you learn about general and special relativity, and that really only happens if you're a physics major. So if you like this, consider studying physics. So right here, we're going to call this our sun. I'm going to drop this in the middle of the sheet, and you see how it makes a huge dent into this the space-time area right here. And these marbles I have in my hand are going to represent the planets in our solar system. So you see, when I toss them around, they kind of make an orbit around the sun. And that's what happens in real life. So a really massive object, like our sun here, likes to pull in other objects because it bends the space around it, causing the objects to kind of tend towards the more massive object. And so this theory can help us explain a lot of things. For one, it helps us learn why gravity, works the way it does. But something else we could do with that is see how stars are formed. So now, pretend all of these little marbles inside my hand are just pieces of dust floating around in the universe. And, they're not too special all by their own. And they're just there, they're floating around in space-time, not really doing anything. But you see, as they get closer together, they start to act like one object and have a pull all of their own. And once enough of them get together, they'll start acting like a heavier object that have a bigger dent in space-time. And now you can see that the new marbles that I'm putting in are starting to orbit around it, just like our sun there. And yeah, once enough marbles get thrown into here, enough gas and dust and whatever else clumps together, it'll start, going into the special reaction that fuels stars. And that's pretty much how stars are made. And you see, you could have little marbles, all the planets orbiting around it. And it'll act, just like our sun did in our previous model. All right, I'm gonna wait for those to stop. I'm gonna pick them all back up. Now, another thing I have to ask you is, when you look at a model of our solar system, you can notice one big thing right away. It's that all the planets, which I'm going to represent with these marbles again, are always spinning in one direction. And, have you ever thought about why that really happens? I know I didn't until I started playing with this thing. So let's take a look and see what happens when we have two groups of marbles going in two different directions. Oh, I threw a couple too fast, but alright. I messed up there. But I need more marbles for this to work. So let's throw a bunch of these at once, and a bunch of these in the other direction. You can see that they start crashing into one another until they all start going around in the same direction. And that's kind of the same thing that happens when a galaxy is being formed. They fly in, planets or big rocks or whatever is out there in space, flies in and gets caught into a star's gravitational pull, and it'll start orbiting around there. And the ones that go into the different directions eventually hit, with planets that are going in the same direction. And last thing I have to talk to you about today is something called escape velocity. So I'm sure you noticed earlier when I was throwing these marbles around, some went into an orbit around the sun here, and some just flew straight off the sheet, like that one just did right there. And that's because this one, if you notice, it was going a lot faster than the other ones I started. So you see when I throw that slowly, it'll go into a nice, slow orbit around the sun. But when I throw it faster, it's able to escape the sun's pull and escape the gravitational attraction it has there. That's all I have for you today, and I hope you enjoyed watching this. Yeah, thank you for your time.